All right, then I need your attention. As we start circles, so I do want to give a sort of disclaimer to start the unit. Today is going to be review, so I know you all know what a circle is, and you are reviewing today the parts of a circle, like radius, diameter, how to find circumference, how to use circumference to find the radius or diameter, and I know that's review. It doesn't mean that is how the entire chapter will be. So there is a lot to remember with circles. There's a lot of formulas, a lot of properties, and different angle measures that relate to circles. So don't let today's lesson set you up to think, oh, this entire unit is just going to be review. I can tune it out. Circles are challenging. This might be, a very challenging unit. As you'll see, the challenging part is just remembering the different properties and how to find the different angle measures and those sorts of things. So today is going to be review. It doesn't mean you should tune it out, just to make sure that you do remember the different parts of a circle, how to work with circumference, how to use your calculator to get a correct answer. That might seem silly, but knowing how to type things in correctly into your calculator so you're not getting wrong answers. So we're starting out defining a circle. So a circle is a set of points that are equidistant from a given point. That might seem like a weird definition. Set of points equidistant from a given point, but that given point is called the center of the circle. And we'll fill in the symbol in a minute here. So in this circle that's drawn, if you put a point at approximately where that center would be, so by definition, the distance from the center to any point on the circle would be the same. That's what that definition is talking about. If I label the center with C, whatever the center is labeled as, that ties into the symbol for a circle. So if the center is C, the circle would be called circle C, and it would be given like this. The circle symbol is like a circle with a dot in it, and then you would put the letter of the center following it. So that would be the symbol that would symbolize circle C. So if you see that, that's what that means. Then the radius, or the plural of radius, we don't say radiuses, we say radii. That is a segment with endpoints at, so one endpoint is at the center and the other endpoint is on the circle. So just looking at this circle off to the side here, can somebody name a radius of that circle? Isaac? CF would be a radius. And so you would label it as a segment, so with that line over the endpoints. Anyone want to name another radius? Yep, CD or DC. So the order you write them in doesn't matter. And then there's one more that's actually drawn on the circle. Ella? CE is also a radius. So if I asked you for a radius, any of those are correct. Any of those are fine. And then a chord of a circle. This is a segment with endpoints that are both on the circle. So both endpoints are points on the circle. So a chord in this circle or for this circle would be the segment AB. That would be a chord. And then last we have here a diameter is a segment that passes through the center of the circle. So that's how a diameter is different from just a chord. The diameter actually goes through the center, a chord does not. It is made up of collinear radii. So made up of two radii. Collinear just meaning they're on the same line. So the diameter of this circle, or the only one drawn in, is DE. or ED, however you want to name that. But both endpoints around the circle has to go through the center. And then the relationship between a radius and diameter, again, as review, so radius is equal to half of the diameter. So I'll put a multiplication symbol here, 1/2 times the diameter, or you're going to see that written as R equals 1/2 D, or you could put D divided by 2. And then the diameter, that means, is twice as long as the radius. So diameter is 2 times the radius, or D is equal to 2R. All right, so actually we've gone through just with our definitions and then having pointed out the radius, chord, and diameter of the circle that was above, we've gone through naming these. So why don't you look at just these 7 practice questions here and just work on those for a couple minutes, and then we'll check them all together to make sure they're correct, but give you a chance to look at this on your own or with someone next to you and make sure you can get them correct. So naming the circle would be the symbol like I had showed you above. Give you another minute here just to answer those, and then we'll check on. All right, looks like we all might be good, but take a look up here to check what you have. So naming the circle symbol, the center is E, so it would be circle E. So there are 3 radii on that circle. As long as you have one of them, it's fine. And again, if you have the endpoint switched around, that's fine too. JK is the only chord. GH is the only diameter actually drawn on there. And then the answers to 5 through 7. Any questions on those? Okay, so just making sure that you understand the relationship between diameter and radius. That was 5 through 7 here. So then we have congruent circles versus similar circles, and then also we have concentric circles. Congruent circles are circles that have congruent radii. So just think as in other shapes as well, if they're congruent, they have to be the same size, which means their radius would be the same length, their diameters would be the same length. Then in terms of similarity, since we just went through an entire unit on similar polygons, specifically similar triangles, every single circle or all circles are similar to each other. Okay, all circles are similar. Every circle is similar to every other circle. And then concentric circles, these are circles that are coplanar, so they just have to be on the same plane, and they have the same center. So concentric means they have the same center. So think circles within other circles is how you would visualize that. So just drawing out what these would mean. So in 8, it says draw congruent circles R and H, and do your best to draw a circle. And if they're congruent, do your best to draw them that they're the same size. So if you drew 2 circles, again, they should be the same size. Just do your best to do that. And then one would have a center labeled R, the other would have a center labeled H. So congruent, same size. And then 9 says draw 3 concentric circles with a center F. So I could draw 1 circle, put F as the center, and that means I have 2 other circles with that same center. So I'm going to draw 2 other circles kind of around that. So think of like almost like a bullseye type thing, a target. Those would all be concentric circles in a target. And then the last one, 2 similar circles named T and H. So here you can draw 2 circles of any size. So if I make one circle larger than the other, since all circles are similar and one has a center of T, one has a center of H. Okay, so that's more of vocabulary, especially concentric, making sure you understand what concentric means when you see that later on. Then we have different ways circles can intersect with each other. So when 2 circles intersect, there are 3 different possibilities for how many points of intersection they have. So they can intersect where they have 2 points of intersection. So in either of these cases, you see there's 2 points where they intersect. They could intersect at just 1 point. So notice they could, well, what we call this here when they're just touching at 1 point, and we'll talk more about this later on. But this is called 2 circles being tangent to one another. When they just touch at 1 point, that's tangent to one another. Or you might have a circle inside of another one and their intersection is on the circle. And then no points of intersection, so not all 2 circles have to intersect with each other. You could have concentric circles. You know, you could have circles that just are not next to each other on the same plane or not touching on the same plane. But when you have diagrams where you do have intersecting circles, you have to use a little bit of reasoning along with what we first did in chapter 1 with segment addition in order to find missing lengths. So 11 gives you the diameter of circle S. So that would be the larger circle. That diameter is 30 units. And then the diameter of circle R, that smaller circle, is 20 units. And then it gives us the segment DS has a length of 9. And it wants us to find CD. So CD is what I'm looking for. And then I know the diameter of S, which that would go from this point C all the way over here. That length is 30. The diameter of R, circle R, that would go from D all the way, if I extended that out, that diameter is 20. And then I know DS is 9. So I would recommend when it gives you something like that, labeling what you know. Anyone know then how we would find CD? Or have a guess as to what CD is and how you got it? Emily?
Well, the radius is half that, so CS is 15.
Mm-hmm.
Add 9 is 24, so the leftover portion is 6.
Okay, so you did CS, so this radius,
Yeah, I did 15 plus 9.
yep, would be 15. And then plus 9 is 24, plus whatever this is has to equal 30. That means CD would be 6. That works. You could also say So yeah, CS is 15, so you could do 15 minus 9 to get the 6 versus the 15 plus 9 and then subtracting 24 from 30. Either way, you'd get to 6. So those types of problems, it really depends on what you're given. I would suggest labeling what you're given, and then it's using problem solving and, like I said, kind of piecing together segment addition or subtraction to get what's missing. So you'll have some practice with that on your assignment. The last part then is talking about circumference, reviewing what circumference is. How would you describe circumference? What is the circumference of a circle? The whole way around. So think of like perimeter. Circumference is the perimeter of a circle. So circumference of a circle is the distance around a circle. But if you wanted to add in there, you can think of circumference for a circle as the perimeter. You just find it differently because you don't have linear sides. And the formula for circumference, there are two of them. The main formula for circumference is pi times the diameter. However, we know the diameter is twice the radius. The diameter is equal to 2r. So another formula for circumference is 2r times pi, or 2 pi r. And then pi, so this is kind of thinking ahead next week to pi day, but pi is the ratio of the circumference to the diameter of a circle. So that's how pi is defined. If you take any circle, if you take its circumference and divide it by its diameter, for every circle that ratio is the same, and that ratio is equal to pi. So that is actually how or where the circumference formula comes from, by just multiplying both sides of that relationship by d to get c is equal to pi times d, pi times diameter. So we have here, you have these formulas and you have to manipulate them to find what you're looking for. So 12 is just asking you to find the circumference given a radius and diameter, and then 13 is asking us to find a radius and diameter given the circumference. I have over here, when you're asked for an exact answer versus an estimate, because you will be, or even on your assignment, some problems ask for exact answers, others tell you to round to a certain decimal place. So pi is an irrational number. We usually, when you first learn pi, you usually learn to just use 3.14 in place of pi. What you should do using your calculators now is do not use 3.14 for pi, actually use your pi key. So I know not all of you have this calculator, but there's a pi key right here. So rather than typing in 3.14, I should actually use that key for pi. So if you have trouble finding that on your calculator, let me know. I know some of you probably use, or if you're using like a phone calculator on your practice and stuff, there is a pi, or there should be a pi key on your phone calculator also. So exact answers though, since pi is an irrational number, it's a decimal, goes on forever, doesn't ever repeat. Anytime you multiply something by pi or divide something by pi, you get a decimal that goes on forever and doesn't repeat. So that would be an estimate if you're going to give a decimal. So estimates will have decimals. Exact answers is when you leave pi in your answer. So exact answers will have pi in the answer. Like you'll give your answer as 10 pi and just leave it. Then if you actually multiply 10 times pi and get a decimal, that would be an estimate. So make sure you know the difference. If I ask you for exact, don't give me a decimal. So for 12, if it says find the circumference, in part A, we're given a radius of 5 centimeters. So since I'm given the radius, I would use the 2 pi r formula. So the circumference would equal 2 times pi times the radius is 5. So the exact answer would just be multiplying 2 times 5, which is 10, and saying the answer is 10 pi. That's exact. So if I said, give me the exact answer, you would stop. If I said, round your answer to the nearest hundredth or nearest tenth, then on your calculators, you would type in 10. You don't have to put the multiplication symbol in between, but you can. So 10, And then if I type pi following it, hit enter, then I round it to be 31.42 if I round it to the nearest hundredth. So this would be approximately equal to 31.42. So it's exactly equal to 10 pi, approximately equal to 31.42, and that would also be measured in centimeters. So try to remember to give the units if the problem gives the units. And then B is giving you the diameter. So with that one, pi times d is your circumference. And since d is 8, that means the exact circumference is 8 pi. Or if I type that in my calculator, 8 pi, enter, it would be approximately 25.13. And that's in meters. So if you type in 3.14 for pi, chances are you will get a slightly different decimal. So I do want you to use your pi key and not type in 3.14. Okay, and then 13, if the circumference of a circle is 106.4 millimeters, find the radius and the diameter. So here you're still using these, either of these formulas. If I'm looking for the radius first, I would, I'll write this here, C equals 2 pi r. So I would substitute in the circumference for C. So that means I have 106.4 is equal to 2 pi r. And I'm looking for the radius. How would I find the radius? Yep, divide by pi, divide by 2. You can divide by 2 pi at the same time, but that you have to be careful how you type it in your calculator. So it might actually be easier and give you less issues with getting the wrong answer if you divide by them separately. So say you divide by 2 first, so that would be 53.2 equals pi r, and then divide by pi. And again, 53.2 divided by, use the pi key, so about 16.93. So radius is 16.93 millimeters. After that, easy way to find the diameter, just multiply it by 2, yeah. So times 2, which would be 33.87. Most problems, if they give you the circumference, they're only going to ask you to find one of these, but if you have to find both, you don't have to use that pi times d formula if you've already found the radius. And find whichever one makes more sense to you first. And then to end, we just have, these are just 2 other vocabulary terms that actually you did see briefly in first semester. I'm trying to remember what chapter that was in. 5 maybe? 5. So talking about inscribing versus circumscribing. So how we would describe, like if you look at this circle, there's a polygon inside of the circle. All 4 vertices of that polygon are on the circle. So we would say then a polygon would be inscribed in a circle if all the vertices lie on the circle. That's how the polygon is described. The circle is described as being circumscribed about the polygon, and that's if it contains all of the vertices of that polygon. So by looking at this is just vocabulary. We would say quadrilateral LMNP is inscribed. I'd say inscribed in circle K. So think inscribed, it's on the inside. And then we would describe circle K as being circumscribed about. Circumscribed about the quadrilateral LMNP. So just if you see those terms, something being inscribed within a circle or a circle being circumscribed about a polygon, you understand visually what that means. all of the vertices of the polygon are on the circle. Any questions? Okay. I will then